The Empty Sky. A historical drama, condensed version. December 1941, The Impossible Problem. Major Thomas Tex Riley stood beside his 90mm anti-aircraft gun at Pearl Harbor, watching the last Japanese bomber disappear into the sky. His crew had fired 47 rounds. Hit rate, 0. The problem was mathematics. By the time a shell reached altitude, the aircraft had moved. Leading the target, shooting where the enemy would be, not where it was, required calculating aircraft speed, altitude, rate of turn, wind drift, projectile trajectory, and Earth's rotation simultaneously. Human gunners simply couldn't calculate fast enough. Riley's best pointer, Corporal Henderson, sat with his head in his hands. "I had them in my sights, sir." "I know," Riley said quietly. Around them, Pearl Harbor burned. January 1942, 3 miracles. Dr. Eleanor Vance stood before a blackboard at the Applied Physics Laboratory, staring at requirements that should have been impossible. Device must survive 20,000 G-forces during firing. Must fit inside 5-inch shell. Must contain radio transmitter, receiver, vacuum tubes, battery. Production, 40,000 units per month. Failure rate, less than 2%. "We need you to build a radio that can survive being shot out of a cannon," Dr. Tuve had said. "Then manufacture 1 million of them." The concept was elegant. A miniature radio in the shell's nose would transmit waves that bounced off enemy aircraft. As the shell approached, the Doppler effect would increase the reflected frequency. When it reached lethal range, the fuse would detonate automatically. No direct hit required. Eleanor's brother David was a gunner on the destroyer USS Mahan. Every day she couldn't solve the miniaturization problem was a day he might die. At the War Department, General Preston assembled the pieces: Eleanor's proximity fuse, VT fuse, Bell Labs M9 director analog computer, and MIT's SCR-584 radar. 3 technologies that could converge into one system: eyes to see the target, brain to calculate the solution, fist to guarantee the kill. "We need 5-fold improvement in 12 months, Preston said. "Give me 3 miracles, gentlemen." June 1942, Trust the Machines. Major Riley stood in rain at Camp Edwards, Massachusetts, staring at the machinery they wanted him to trust: an 8-foot radar dish, trailer full of humming electronics, and the M9 director, a refrigerator-sized computer connected directly to his gun. "It calculates firing solutions 30 times per second, explained Harry Murphy, the exhausted Bell Labs engineer. "Your crew just loads and shoots when it tells you to." "And aims where?" Riley demanded. "At empty sky. At where the target will be, not where it is." Riley looked at his experienced gun crews. "You want us to ignore what we see and trust a machine?" Murphy showed him test results. Optical fire control scored 7% hits. The M9 scored 62%. "Major, wars aren't won by feelings. They're won by physics." Riley thought about Pearl Harbor. About firing until his crew's ears bled while Japanese bombers flew untouched. "Show me how it works." March 1944, Field Testing. Eleanor stood in Italian rain beside a corroded shell that had failed to detonate. The young loader looked at her with something harder than gratitude. "They work pretty good," he said. "Except when they don't. 1 in 6 shells this month." Eleanor photographed the corrosion pattern, her hands shaking. 18% failure rate. At 40,000 units per month, that meant 7,200 duds, 7,200 chances for soldiers to die because she hadn't been clever enough. German artillery began shelling the position. Eleanor found herself face down in Italian mud while the earth shook and metal fragments shrieked overhead. This was David's life. This chaos, this terror, this arbitrary mathematics of survival. When it ended, she made her decision. "Captain Bronson, I need to see every forward battery. I need to catalog every failure mode. 5 days touring the front. 5 days examining duds, interviewing crews, understanding how laboratory perfection degraded in mud and rain and salt spray. Your fuses changed the war, Major DeMarco told her. Before VT, we fired 3,000 rounds per kill. Now it's 300 rounds per kill. That's tenfold improvement. But the failure rate is acceptable, DeMarco interrupted. War is about choosing between imperfect options. You've given us the best weapon we've ever had. January 1944, Anzio. Riley crouched beside his battery as German Stukas dove on the beachhead. The M9 director whirred to life, calculating intercept points. Battery ready, Henderson reported. The guns pointed northwest, 45 degrees away from the visible Stukas diving from the northeast. Every instinct told Riley those positions were wrong. But he had learned to trust the mathematics. Fire mission. Commence firing. The guns roared. Shells climbed toward empty sky. The first Stuka entered the kill zone and explosion. The aircraft shuddered and spiraled down trailing smoke. Hit. Sergeant Willis screamed. Target destroyed. 4 Stukas attacked. 3 destroyed, 1 driven off. Total engagement time, 42 seconds. Riley had never seen such efficiency. Henderson was grinning. Sir, remember Pearl Harbor? 47 rounds, 0 hits. Tonight we fired 32 rounds and killed 5 targets. Riley finally understood, this wasn't replacing human skill. It was augmenting it. The M9 made gunners deadly. June 1944, London's Shield. The first V-1 buzz bomb appeared on Riley's radar at 11:47 p.m., June 13. 400 knots, faster than any manned aircraft. The VT fuse had been authorized for use over land for the first time, despite the risk of Germans recovering a dud. The threat to London was too great. Fire, Riley ordered. Shells streaked toward an intercept point 6 miles away. Through darkness came an orange flash, the V-1 destroyed over the English Channel. For 4 hours, Riley's battery engaged wave after wave. 17 V-1s. 16 destroyed. By dawn, Murphy brought preliminary numbers, 79% interception rate across all batteries using M9 and VT fuse. Major, we've almost doubled the effectiveness of air defense. We're saving hundreds of lives daily. Riley thought about Pearl Harbor, about impossible mathematics. Now his crews aimed at empty sky without question, trusting machines to fill it with death at exactly the right moment. December 1944, the final improvement. Eleanor stood before General Preston, surrounded by skeptical officers. New battery seal reduces failures from 18 to 3%, she explained. But retooling requires 4 weeks with 0 production. Dr. Vance, we're fighting the Battle of the Bulge, Colonel Matthews objected. We need ammunition now, not better ammunition next month. Can you look me in the eye, Eleanor said quietly, and tell me we should keep manufacturing defective ammunition when we can fix it? Preston studied her. How confident are you? 500 test rounds. 15 failures total. 3%. Preston authorized the halt. 30 days, Dr. Vance. Not 31. The production line restarted January 18, 2 days early. The first telegram arrived within a week. 20 rounds fired in Ardennes. 20 detonations. 0 failures. Outstanding work. May 1945, victory. 22 million proximity fuses manufactured. Estimated 300,000 Allied lives saved. Final reliability, 97.2%. Riley met Eleanor at the War Department award ceremony. Dr. Vance, your work saved lives in my battery. Probably saved my life. I should apologize for the early failure rate. Stop, Riley interrupted gently. 18% failure on VTE fuses was infinitely better than 80% failure on time fuses. You gave us the best weapon we've ever had. They talked for an hour. Riley described trusting the M9, firing at empty sky. Eleanor described the desperate push for reliability while maintaining production. What will you do now? Riley asked. Eleanor looked at her hands. For 3 years, her work had been urgent, vital, necessary. Now that urgency was gone. I don't know, she admitted. Rest, maybe. Riley smiled. You earned it. Remember, perfection was never possible. You did the best you could with the time available. Good enough was actually good enough. Epilogue. General Preston's speech was brief. These engineers solved problems considered unsolvable. They mass-produced weapons requiring laboratory precision. They proved that mathematics could triumph over chaos, that human ingenuity could bend physics itself to serve strategic purposes. History will remember this war for radar, computers, nuclear weapons. But the proximity fuse represents something fundamental, proof that genius, properly focused, can overcome any obstacle. After the ceremony, Riley found Eleanor outside. Pearl Harbor broke something in me, he said quietly. Standing with a useless gun while planes I couldn't hit dropped bombs on ships I couldn't defend. Your work fixed what Pearl Harbor broke. You restored our ability to defend ourselves. That's not just genius, Dr. Vance. That's salvation. Eleanor felt tears in her eyes. For 3 years she had carried the weight of imperfection. But Riley wasn't talking about failures, he was talking about the 97% that worked, about cities saved, about soldiers who came home. Thank you, Major, she said. For trusting the mathematics. For aiming at empty sky when instinct said otherwise. Riley saluted and walked away. Eleanor thought about numbers, 22 million fuses, 300,000 lives saved, 97.2% reliability. She thought about the 2.8% that failed. But mostly she thought about Riley's words, you restored our ability to defend ourselves. The legacy of the proximity fuse wasn't just clever engineering. It was giving American soldiers a fighting chance. Mathematics had defeated chaos. And human ingenuity had bent history toward victory. Eleanor Vance had tried to build perfect weapons and failed, perfection was impossible. But she had succeeded at something more important, building weapons good enough to win a war. And good enough, she finally believed, was actually enough. In the empty sky above cities that were saved, above ships that survived, above soldiers who came home, in that empty sky filled at precisely the right moment with 22 million small miracles, there remained an invisible monument to human genius under pressure. The end.